Hi everyone, welcome to the Data Structures and Algorithms session 3, session 1 and followed by session 2, section 1, 2, 3, 4. We are on to the session 3 of DSA, what we call. This is for the PGD AI, PG degree in Diploma in AI, Data Structures and Algorithm Preparation, session 3 of 7. And Jamit has been doing an excellent job. He has been holding these sessions. So I will hand over to him and welcome to Jamit. Please take over from here. Thank you.
Thank you, Prakash sir, for the introduction. So, hello everyone. Welcome to the DSA's session 3, which covers the stacks and queues. Till now, we have covered the singly linked list, in a way linked list, and separately done the singly linked list, doubly, and circular list. So now we are discussing the stacks and queues. So let's get started. So stacks and queues, why they are approached the way they are approached. So often it is important to store data and retrieve them later in the process. So for example, order like main function calls sets of functions f1, f2, f3, and the records may be stored program. Program may save state of f1 in r1, f2 in r2, and f3 in r3. Now, while returning it, it may retrieve them in reverse order, which is R3, R2, and R1, which is called last in first out order. And on the other hand, one may just recall back a stored R1, R2, R3 in first out order. So there's a specific name to these type of data structures to store and retrieve them while processing, and they are called stacks and queues. So stacks follow a LIFO order, and which are efficient in data structure for storing and retrieving data. So it allows us to retrieve data in the opposite order it was stored in. So you can see the visual representation of a stack and a queue, where stack follow the LIFO and LIFO or last in first out, and queue follow the first in first out order. Some applications of stacks and queues are Cephalo's programmatic device for synchronizing access to shared resources. Then event handling. Queue keeps track of events so that they can be processed at a later time in the order they were received. Then X window systems. X is a specific example of system that does event handling to manage events. It uses a queue to store events until they can be processed. The producer-consumer problem, a generalization of modeling cooperating process where one process, the producer, writes the queue shared by another process, the consumer, which reads from it. There are many examples to producer-consumer problem also, which can later expand. So moving further, we have a function called NC. A stack is the perfect model for this because when functions call one another, they return in the opposite order as they were called. And the abstract state machines, an abstraction used by compilers and handheld calculators to evaluate expressions. So these were some of the applications of stacks and queues. Now let's start first with stacks. So stacks is anything you can imagine of being stacked, like here it says a tennis ball stack, or stacks of plates, which fills from bottom to top, but empties from top to bottom, which is the LIFO order. So you can see in the image representation also that we have 3 and 5 in the stack. Then we are pushing 2, 9, 8, and then popping out 2 and 9. Sorry, we are pushing 8, 9, and 2. Sorry for mistake. We are pushing 8, 9, and 2, and then popping out 9 and 2. Sorry, popping out 2 and 9. So these are the interfaces of stack that we'll be using in order to represent the stack in the program. So stack init for initialization of stack, stack destroy for destroying the stack or the memory allocated to it, then stack push for pushing the elements into it, and stack pop for popping the element from it, stack peek for returning the top value that is present at the head of the stack, and stack size for returning the size of the stack. So this is one just a way to implement the stack that will be later on referring it into an IDE also. So let's refer to the stack first. So this is a list.h header file that we have discussed before that makes use of single linked list operations of list insert next and list remove next, which basically from the selected elements it removes or inserts the element which we have discussed in the single linked list. And then we are implementing the stack here, and these are the interfaces that we'll be using. You can see the push and pop operation being defined over here. Now these will be included as a stack.h, and this stack.h will be used over here in the main program. So stack.h and list.h, both of them are being used instead lib for the malloc, for usage of the malloc function. Now it's we are pushing the stack we are defining the stack push, so to push the desired data, and as described that we will be using the list insert next function for stack push, and then for stack pop or removing the element we'll be using the list remove next function. So this is the basic these are the basic operations of stack in the C program. Now let's get back to queue. So the distinguishing characteristic of a queue is that it stores and retrieves the data in first in first out order or a manner. So this means that the first element placed in the queue is the first to be removed. A convenient way to think of a queue is as a line at the polling booth or any kind of a queue. So a queue with some elements already enqueued, as you can see in the image below, that we have 5 and 3 as the elements. Then after enqueuing 8, 9, and 2 in step 2, and at step 3 we are dequeuing, or we are dequeuing 5 and 3. So head becomes 8 and tail becomes 2. So so similar to the interface that we have discussed for stacks, we'll be discussing a bit of interface over here for queues as well. A queue init for initialization of queue, queue destroy for reallocating the memory, then queue enque for, or queue enque for adding the elements to queue, deque for popping or for removing the elements, queue peek for returning the value at head, and queue size for returning the value of size. So implementation and analysis of queue. So similar to the stack.h, this is the queue.h, and that will be discussing more on the editor. So this is the queue.h that we have found for a list. So this is the implementation of queues as a linked list. You can see the queue enque and queue deque for list it. Then we have list init, destroy, queue peek, and queue size. you can see some of the comments being added for more for simple or a brief explanation of the commands that are entered. So let's get to the C program. So these are the header files that we'll be using. We have Q for enqueuing the data. We'll be using the list insert next here, and deque for removing the data, and we'll be using the list remove next. So this was the implementation of Q, or normal implementation in a C program. So let's use it on some real world example. So one of them is event handling. So one popular application of queues is handling events in event-driven applications. Event-driven applications execute largely under the direction of real-time occurrences called events. In nearly all event-driven applications, events can occur at any moment. So queues play an important role in storing events until an application is ready to deal with them. So a queue works well for this because applications handles events more or less in the same way as they occur. So events are basically something when interacting with a GUI, the user clicks or key presses, and an event is triggered. So for handling those events, we'll be discussing in events.c. So first, these are the receive event and process events, and that we'll be using. So receive event is basically whenever an event is triggered, the receive event will be receiving the event, whenever it will be notified, it will be receiving an event. And whenever a process is ready to deal with the event that a receive event has, the process event will be accepting the event and using a dispatch function, which is an application specific dispatch function. The dispatch function's job is simply to take the appropriate action for handling the event. So these are the contents of the events.h header file that we have made. Then this is the events.c file for the whole C program. So as I said, first we will discuss the receive event. We'll be creating a new event and allocating the space for it, and making a copy of event and enqueuing it. For process event, as discussed, this is we'll be processing the event, then return if we don't find any event, then we'll be returning the -1 value. Else we'll be using. Okay, so then we'll be using the deque. If it doesn't find it, then we'll be for that or for unsuccessful retrieval, we'll get the error code of -1. And if all has been satisfied, and then in the sorry, if we have got the event that we want, and then we'll be calling the dispatch function and event to it, and free the event from here. And for all the successful execution, we'll be getting the return code of 0. So additional topics for queues are polymorphism, refers to same symbol, or as you can see that we have we have implemented a linked list or a single linked list for the example or the showcase of stacks and queues, both of them. And so that is what we call polymorphism. So polymorphism refers to same symbol or a word being used for multiple interpretations. Example, plus a symbol used for addition on numbers as well as the concatenation of strings. And then for DQ or DQs is similar to plus below. So double-ended queues, often called DQs, pronounced as deques for short. A deque is deque is more flexible queue that allows the insertion and deletion at both of its head and tail. And circular queues akin to circular list. As with circular list, circular queues do not have a tail. Instead, the last element is the queue, and the queue is linked back to the first element so that the queue can be traversed in a circular fashion. Yeah, so this was the presentation regarding the stacks and queues and some of the codes that follow it. We discussed about the stacks.h, then queues.h, and events.h for the respective header files, as for the respective files or the code of .c files. So this was it for stacks and queues. Later on, we'll be covering the sets after this. So thanks a lot for listening. Thank you.
Excellent. Jamie, this was good, and especially the dispatch being brought in as part of the application so that you can um, dispatch and then not worry about the queue and be able to uh, pass on to application the processing.
Yeah.
And that was part of the queue. Earlier, you had covered the obviously the stack, the push and the pop, which was also using the queue and enque and deque for queuing, as well as removing from the queue. So this was the data structure following whatever we had done, the what you call the linked list, circular linked list, doubly linked list, etc., and also the um, what you call the frame management. So which was part of the memory management. So you've done till now what is required, and now next session we'll be moving on to uh, sets and thereon further to uh, hash table and priority queues and other data structures. So I think we are reasonably uh, brief this time, and hopefully next session also will be similarly brief and be able to help everybody prepare for the PGDA. And thank you very much. And I think with that, I will stop the recording for today.